In a world filled with conflicting opinions, information overload, and growing mistrust, one question seems to gain more and more popularity. Can we trust science? For centuries, science has been the driving force of progress, but despite its contributions, skepticism toward science is growing. Today, science faces growing opposition from various groups. Misinformation spreads faster than ever. Whether it's debates over climate change, vaccines, or even the shape of the Earth, science is constantly being questioned. But why? Although science in popular belief may translate to knowledge about something in general, it actually has a precise definition. Science is a systematic discipline, a methodology for answering questions that could be answered through objective and physical experimentation. It is neither a tool to disprove something metaphysical like God or even find out the true nature of the universe. But despite its limits, the scientific methodology has given us immense power, from space exploring to life-saving vaccines and revolutionary technology. This methodology is built on observation, testing, and evidence, helping us to understand and model the world around us. And then we must test these models, and if they survive any experimentation that we could throw at them, then they can stay. Now, here you might start to see the limits. Although one model may prove to give us very precise description of our real world, it only has been tested based on the context of the experiments. This means that, for example, we could never run experiments outside of our technological capabilities. For example, the gravitational model of Newton works perfectly well for objects not very massive or not approaching the speed of light, which are the contexts based on which Newton's model were defined. Now, one could say that based on Einstein's relativity, Newton was wrong, but Newton never tested his model for objects moving near the speed of light. We have to keep in mind science is not an egocentric game, it is simply forming models based on specific contexts and testing them that way. Now, this is one of the points that might cause confusion and mistrust of people in science, because unfortunately journalistic reports of scientific findings are often portrayed as some smart people figuring out how the universe works, and then another journalistic report claiming that those first people were wrong, making things about people, not methods or experiments and the context of the experiments, because that would just not get views. In fact, media plays a huge role in a world where clicks and views drive content. Sensationalism often takes the lead over the actual facts. Also, we should not forget the emotional side of a good journalistic story. What gets clicks are often what makes us feel something, and the feelings we have towards something are often tied to identity and values, which are based on different belief systems. This makes facts harder to accept or even understand if they contradict deeply held beliefs. Moreover, different ecosystems want to get more views and attention, so they design algorithms that we would like because they resonate more with our beliefs. This in turn pushes us towards information that aligns with what we already believe, reinforcing our biases. This creates echo chambers, where people only hear what they already agree with, further dividing facts from beliefs. Science isn't about absolute certainty, it's about getting as close as possible to a model that we can understand, which also happens to describe our world through evidence and repeated testing. And it's always open to correction when new evidence emerges, because in this methodology we cannot run experiments in the future or with technologies that we have not yet invented. This means that scientific models in a sense are also based on a trust that the laws of the universe, whatever they may be, do not change in the unseen future, and whenever they do, the models must simply change. Science is not perfect, it has its limitations and mistakes do happen, but its strength lies in its ability to self-correct, evolve and continuously strive for more accurate understanding based on objective measurement. To bridge the gap between facts and beliefs, we need to focus on education, media literacy and open dialogue. Learning to question sources, think critically and engage in conversations with an open mind is key to restoring trust in science. In the end, the question isn't whether we should trust science, but how can we make sure that science continues to serve humanity based on evidence, transparency, and a commitment to truth. Because when facts and beliefs collide, the truth is always worth fighting for.